Hi and welcome. Internet Protocol Security, or IPsec, is a suite of network security protocols which are used to provide authentication and encryption services to Internet Protocol or IP. In this video, I will discuss Internet Protocol Security or IPsec, including its various subprotocols and components, that is, Encapsulating Security Payload, Authentication Header, Internet Security Association and Key Management Protocol, and Security Associations and Internet Key Exchange. Before moving further, please turn on the subtitles for this video. Now, Internet Protocol operates at layer 3 of OSI model, that is the network layer. So once the Internet Protocol was designed, it was designed for the government networks. Therefore, security was not a consideration since this government network was physically secure. Later on, Internet Protocol Security or IPsec was introduced as an extension of Internet Protocol to provide security services to Internet Protocol packets. And IPsec also operates at layer 3 of OSI model. Now there are certain other protocols which operates at higher layers of OSI model, that is the layer 7 or application layers, and this protocol or these protocols are secure shell and transport layer security. But IPsec can also provide security to the higher layer data since it operates at layer 3. So once we talk about the history of Internet Protocol Security, National Security Agency in 1986 introduced a program called Secure Data Network System Program, and they run this program from 1986 to 1991. And the purpose of this program was to design security protocols for the security of Internet. Now, a part of these security protocols, certain security protocols at layer 3 were further enhanced and improved by various stakeholders from 1992 to 1995. Then in 1995, Internet Engineering Task Force standardized these protocols and published an RFC, which was the implementation of Naval Research Laboratory of United States. So the first implementation of IPsec was from Naval Research Laboratory in 1995. So IPsec is open source and is an open standard, and it is modular, and it provides encryption and connectionless authentication services to IP packets. And IPsec or Internet Protocol Security is also used to establish a virtual private network between two gateways, that is the networks, and between two hosts or between a gateway and a host. So virtual private networks or VPNs are used to extend the private network over the internet. Now IPsec operates at two modes of operations, that is the transport mode and the tunnel mode. So once we talk about end-to-end communication, then it is the transport mode. And once we talk about the security or the communication between two networks, then it is normally the tunnel mode. Moreover, IPsec also used to provide security or confidentiality to layer 2 tunneling protocol. So IPsec provides confidentiality, peer authentication, which is connectionless, and data integrity, and also the source integrity and replay protection and access control services at layer 3. There are certain issues with IPsec that it reduces the throughput of the network to up to 80%, and moreover, network address translation or NAT has some issues with the IPsec. Therefore, we use NAT Traversal to overcome these issues. So IPsec can also create iterative tunneling. It means that two IPsec tunnels are created inside each other. For example, one tunnel may use the transport protocol, and other tunnel may encrypt this transport mode into tunnel mode. Now NSA has developed a device which is a encryption gateway, and it is known as high assurance IP encryptor device, and this device uses IPsec. Now in 2013, Edward Snowden revealed that the NSA has cracked the IPsec protocol. Now there are two sub protocols which are used inside IPsec, that is the Encapsulating Security Payload, which provide encryption services to IPsec or IP, and second is the Authentication Header or AH, which provides connectionless integrity. So I will show you the structure of a packet. So this is the application layer data, and this is the TCP header which operates at layer 4, and this is the internet IP header which operates at layer 3, and this is the Ethernet header which operates at layer 2. Now ESP header is added and inserted between layer 4 and layer 3, and it provides encryption services to the data after it, that is the layer 4 data and above till layer 7. So ESP header does not encrypt the IP header, but it only encrypts the IP payload or IP data, which is the upper layer data. Now AH or authentication header provide connectionless data integrity, and this is the application data, and this is the TCP header which operates at layer 3, and this is the IP header which operates at layer this is the TCP header which operates at layer 4, and this is IP header which operates at layer 3, and this is the Ethernet header which operates at layer 2. Now AH header is added between after the IP header and before the Ethernet header. So it provides data integrity and non-repudiation to the data above it. So it also adds a new IP header after it encrypts the data above it, that is the IP header. So, and all the IP payload. So ESP header does not do anything with the IP header, but AH also include the IP header. Now once we talk about ESP or Encapsulating Security Payload, so it is used to provide confidentiality or encryption and limited non-repudiation, since it does not encrypt the IP header, and it only encrypts the IP payload or IP data, that is the layer above it. So it encrypts the IP payload, not the IP header, and it is mainly used to provide end-to-end security, that is between a client and a server. And it can also be used to provide link encryption, that is between two networks and two sites. But mainly once we refer to ESP, it is used to provide end-to-end security. So ESP can be used in tunnel mode, or it can be used in transport mode. So once ESP or encapsulating security payload is used in tunnel mode, it is used between two gateways, or between a gateway or a host. So either side should be a gateway. So in tunnel mode, it encrypts all the data, that is the IP header and all the data above it. But once it is used in transport mode, it only encrypts the IP payload, not the IP header. So it is used for peer-to-peer, that is between two hosts, or between a host and a gateway. So either side should be a peer or a gateway. So in tunnel mode, either side should be a gateway, and in transport mode, either side should be a host. Now, a network intrusion detection system, or NIDS, can monitor the traffic before it is tunneled, or so it can monitor the traffic on the lane before it is tunneled, and after it is tunneled, then NIDS cannot monitor this traffic. And in transport mode, since it is end-to-end encryption, therefore we use host-based intrusion detection system on the host after the traffic is decrypted at the host. Now ESP can be used with authentication header, or it cannot, and it can be used without authentication header. So once it is used with authentication header, it is used in tunnel mode, since authentication header only works in tunnel mode. And once it is used without authentication header, it is used in transport mode. Now authentication header provide connectionless data and origin integrity, and we can also say that these both data integrity and source integrity combines into non-repudiation, in which the sender of the packet cannot deny that he has not sent this packet. So it does not provide confidentiality, but it provides replay protection, and it also tunnel the data, and it provide signing services to the data. So in authentication header, we also encrypt the IP header and also the IP payload, and a new header is added, which I have showed you earlier. So it provides link encryption, that is between two sites and two networks, and authentication header is only used in tunnel mode, and it's not used in transport mode. So it is used between for communication between a gateway to gateway, or between a gateway and a host. So either side should be a gateway, and it is not used in transport mode, in which either side should be a host, or it can be a gateway as well, that is between client and server. So there are certain issues with authentication header, since it encrypts the IP header, therefore routing, encryption and decryption creates some issues for the devices which are between the source and the destination. So it is very rare to see that the authentication header is used without ESP or encapsulating security payload. And encapsulating security payload provides confidentiality to authentication header, and authentication header provide data integrity and source integrity. Now there is an issue of network sniffing on the lane, since the tunnel is established between gateways. So after the tunnel is terminated at the gateway, then the traffic can be sniffed by the hacker on the LAN. Now there are other protocols, that is the Internet Security Association and Key Management Protocol, or ISAKMP. Now ISAKMP, or Internet Security Association and Key Management Protocol, is a framework for creation of security associations and key exchanges, and it provides background security services for these purposes. So it is used for authentication and denial of service protection and replay protection. So ISAKMP is a framework, and actual key exchanges can be pre-shared, or it can be through internet key exchange, or it can be through collaborative internet negotiation of keys, where we use a third party or KDC, or key distribution center, for distributions of keys between two endpoints. Or we can also exchange keys using IPsec key resource record, where the public keys of domains are published. So it uses DNSSEC or DNS security for communicating the public keys of domains. So security associations, or SAs, are actually the session parameters for authentication header and encapsulating security payload. And there is a security parameter index which is of 32-bit, and this SPI denotes the security association. So security association is simplex, that is, we have to create two SAs for ESPs, one SA for each direction, and then two SAs for authentication header. So if we are using AH and ESP both in IPsec, then we need to create four SAs for two directions, one SA for incoming and one SA for outgoing. So we can also filter the IPsec traffic based upon security associations, or SAs, and we can filter various services and protocols. Now internet key exchange is used to set up security associations, and these are based on X.509 digital certificate for authentication, and this can be pre-shared, or it can be shared through DNS. Now there are two phases in internet key exchange, or IKE, and in phase 1 the ISAKMP, or Internet Security Association and Key Management Protocol security associations are established, that is through Diffie-Hellman for key exchange, and this is actually the management traffic to establish a policy for the devices. And this security association is bidirectional, that is, we have to create only a single security association for both sides. Whereas in phase 2 of this internet key exchange, IPsec SAs are established, and this is established for data protection, and these are simplex and unidirectional that I have explained earlier as well. That is, we have to create two essays for each direction. So the general rule is that the highest protocol will be selected by Internet Key Exchange. So the most secure protocol will be used. For example, data encryption standard or DES is superseded by advanced encryption standard, that is AES. So this was all from my side. Please stay connected to my channel for similar videos. Thank you.